A ball is thrown vertically down towards the ground with an initial velocity of 4.23 meter per second. The ball falls for a time of 1.51 second before hitting the ground. Air resistance is negligible. So it means there is no air resistance. So it means A is equal to G. Show that the downward velocity of the ball when it hits the ground is 19. Mr. Show that question. Initial velocity is given. And time is also given. So downward velocity means you need to find V. So can you suggest a formula for V?
V is equal U plus AT.
Very good. V is equal to U plus AT.
It is coming as 19.
It's coming whole 19.
19.04.
So solve with me and just write the year number. And as I'm always suggesting my students that if you are doing older papers, so better to use a digital device, writable device, any iPad or any other device in which you can write, so that you write in the space. And the most important skill, as you have told me just now, that you are facing some issue with the time and one paper gave you a time issue. So this is the biggest problem. Time constraint is a big challenge. Calculate to 3 sig feet the distance the ball falls to the ground. So we have a lot of data and we need to find the height.
We can use the V squared minus U squared equation too.
Yes, right. We can use this, or we can also use this. Because we have a lot of data, so we can use any one of them. We need to find S.
It is coming as 17.48.
17.48. How many sig feet do you think I should take?
We should use 17.5.
Yes, very good. The ball makes contact with the ground for 12.5 seconds and rebounds. It's a rebound, one of their favorite case, with an upward velocity of 18.6. The mass of the ball is 46.5. Average force acting on the ball on impact with the ground. So you hopefully remember that this average force concept comes from the definition of the force. Force is the change in momentum upon time interval. It's a rebound case. So ball is striking at 19. Ball is striking at 19. The time of contact is 12.5 millisecond. Unit conversion is something which is their favorite. Now, if I take U as 19, the V, which is the rebound velocity, I should take it minus 18.6.
So mv minus u will be the change in momentum.
It's a formula for impulse now. Dynamics, remember dynamics, Newton laws and change in momentum. Do you remember the 2D momentum chapter?
The p is equal mv.
Yes.
So why will we use the velocity as minus 18.6?
It's a rebound now. Ball drop and rebound. So if the drop velocity is plus, the rebound velocity would be negative, change in direction.
Okay, so first we'll take minus 18.6 and then minus it with 19 again.
The first velocity should be conventionally taken as positive. Let me know once you get the answer.
I'm getting as 1.49 Newton.
1.49. It's a very small force. Something is, can you double check? 1.49 is a very small number.
I took the u first and then the v. So I did 19 minus 8.6.
But they will be eventually added now. In any way, it doesn't matter you take V minus U or U, but they will be added because both are in the same sign now. Whatever you do in maths here, you put V minus U or U minus V. Actually, they will be added. Because minus 18.6 minus 19.
Okay, I got it now. I got it. So because of the minus minus, we take it as plus.
Yes. We will get a minus in answer, no problem.
Now I'm getting as 138.4.
I can take 138 for 3 sig fig or 140 if I take 2 sig fig. Use conservation of energy to determine the maximum height the ball reaches after it hits the ground. The ball rebounds. So when the ball is coming down, there is a loss of potential and gain in kinetic. Then the ball rebounds. So after rebound, the kinetic energy of the ball converts into potential energy. Kinetic energy converts into potential energy. So I write this formula. This is a working. Loss in kinetic is equal to gain in potential. I have to show working.
So the direction of the force in the up question above, will it be down?
Sorry, I missed it. You're right, upward.
Because
Because the
it's
ball is rebounding. So when something is rebounding, it's going upward. What would be the direction of the force?
upwards.
Yes. Now, let me know. Examiner says maximum height. What would be the velocity at the maximum height?
0.
Very good. So I took 0. What is the rebound velocity? By what velocity it was rebounding? 18.6. When it is going upward, it will reach a maximum point. Now, you have to do the working. You have to copy this working and do the solution.
I'm getting a 17.6 meter.
Can you repeat 17 point?
0.6.
It looks fine. Even though the ball appears to go quite high, but it's okay, looks good. State and explain whether the collision the ball makes with the ground is elastic or inelastic. Do you remember elastic and inelastic, how we used to differentiate it between them?
The total energy was equal, but the kinetic energies were different.
And then it is inelastic. And if kinetic energy also conserved, then
Then it is elastic.
very good. So you can see the ball was coming down. The ball was coming down with a velocity of 19. The ball was coming down and striking with 19. but the rebound was 18.6. So do you think some loss in kinetic energy has occurred?
Yes, it can be lost to like thermal energy or sound energy.
Yes. So what should I say now? State and explanation. Is it an elastic collision or inelastic?
It will be an inelastic collision because the velocity upon like falling down and coming up and the rebound, it will be different.
Good.
Thus, the
So
kinetic
the
energy
answer would be it is a
inelastic.
hmm. So the answer would be collision is inelastic. He says explain. He's giving us 1 mark, but asking for 2 things. So you will have to explain it. You will, as you said, that the rebound velocity is less than strike velocity. You will tell the examiner that, look, rebound velocity is less than strike velocity. So if this means that the collision is inelastic. In dynamics, inclined plane, I hope you remember, this is one of their favorite topics, inclined plane. So now you see this question.
Also, I forgot to mention earlier, but like the questions on the forces, like sometimes the upthrust or the water tension, I'm facing problems in those two.
That's good. Can you make a can whenever you get a issue like that, can you post me, and whenever we can schedule, I'm putting classes for these topics in different groups and with my students. So I can tell you, even we can put a class here next time. If you keep on recording the issues, like you have sent me a paper, and I will inshallah put it in a class, so you can also join that, because everyone has having problems. So it's a type of sharing now. So you can please post me this issue. The chapter name is forces and the topic is upthrust. So I can share class, and also I can share you if I have a recorded work. Question doing is the most important right now. So I'm keeping it with everyone, but time constraint is it's a huge syllabus. You can see for every topic, even in paper twos, if you are doing till 2012, there are 50, 60 questions, even more than that. So please WhatsApp me this also. A motor drags a log of mass 450 kg up a slope by means of a cable. The slope is inclined at an angle. Do you remember we used to call it theta?
The 14 degrees.
Yes. Angle should be given in 1 decimal place. This is an inclined plane question. Show that the component of the weight of the log acting down the slope is this. So can you help me to recall, if I make here, this arrow is mg. Is
This
it
will,
right?
yes, at the center of gravity, it will show the weight.
And then I resolve it. Remember, we had a resolution sign here,
Yes, the mg cos theta and mg sin theta.
and here it is mg cos theta, and here it is mg sin theta.
Isn't mg cos theta on the vertical side, on the horizontal side?
Do you remember what was the rule where cos will come, where sin will come?
Like where it was adjacent with the, where it was
No,
touching the.
where the angle is touching. Now you reach. This is the angle. What was R?
The resistive force L.
No, the perpendicular R.
Oh, the normal reaction force.
Yes. So this is the normal reaction. So I have marked the arrows. He says weight of the log acting down the slope. So what component he is talking about?
Also, I forgot to mention I got the marks for the mocks exam I gave.
Acha, just let me stop the recording because I have to upload this on the YouTube now. Just a minute. Once you get the I stopped here and we were discussing show that the component of the weight of the log acting down the slope. So now, can you help me? What is the down the slope component here? Which one?
Down the slope will be mg cos theta.
Eh?
No,
No,
sin theta, mg sin theta.
how it can be mg cos theta? Mg cos theta is vertically down. So he's talking about mg sin theta. What is m? 450 kg. G will be 9.81 and it will be careful, the calculator must be in degree mode. It will be a serious error if it is not in degree mode.
I am getting 1073 Newton.
17, can you repeat 17 point?
1073.
He says 1070, so it's a sig fig issue. And I have rounded it.
Along the slope, it will be the mg sin theta, and like vertically below, it will be the mg cos theta.
The slope means if you say go down the slope, if someone says go down the slope, it means go on the slope downward. Down the slope never means mg cos theta because mg cos theta is perpendicular to the slope. The log starts from rest. A constant frictional force of 525 Newton acts on the log and accelerates up the slope at 0.13. He says accelerate up. So they are taking the slope up. If they are taking the slope up, can you tell me where should I show the friction? Upward, downward? It's going upward. The object is going upward. So friction will be upward or downward? Do you remember the rule? Friction always opposes the motion. Friction
It will be up.
always opposes the motion. Right? So now tell me, where should I show the friction?
If it is going downwards, the friction will be in the opposite direction.
The object is going upward.
Then the friction will be downwards.
Good. And he is pulling the object. So I'm showing the tension. Now, how many forces are acting?
Tension will be the opposite direction as the friction.
Because you're pulling it. You're pulling you're pulling the object upward. So you're pulling it upward. It is the tension, which is the driving force, friction, and mg sin theta are opposing the motion. Now, can you help me making the equation? Do you remember the formula which is frequently discussed? Resultant force is equal to greater force minus smaller force. Now, can you help me from the diagram? Where is the Greater force.
The greater force will be towards the T.
Yes. So I put it as T. What are the two smaller forces?
Mg sine theta and F.
So I will write mg sine theta plus friction. That is why I always advise that if you are doing a paper with me and the question is not with you, you should have a writable device and you can work with me, because you know the working I have done on the diagram, that is the core. That is the core. And if you have any digital device with you in which you can write, you can work with me and you can save the file and it will be a solved paper for you. Actually, the main issue is the force diagram. Once it is ready, then the question never goes wrong. Now, can you let me know that do we have the mg sine theta as a whole value?
1070.
So I will take 1073 on a safe side. What is the mass? 452. What is the acceleration? 0.130. Friction is given to be 525. Look, I'm showing all the steps. This is very important because if you make a mistake, then examiner can award you the working marks and even BOD if you have shown all the steps, because in paper, everyone has to work very quickly. And that quick work definitely leads to many errors. So I have done all the steps. So you have to share the steps and help me for the calculation.
I'm getting the answer as 1656.8, like 1660.
Can you tell me the numbers? 10?
The answer
Yes, yes.
1665.8.
Okay. Excuse me. 116.
1656.8.
The log is initially at rest at point S. It is pulled through a distance of 10 meter to the point P. Calculate the time taken to move from S to P. Examiner now giving the situation that this is the angle theta and the log was here. This position is S and it has been pulled to a new position P. It was at rest. So U is 0. Distance of 10 meter. So the distance of 10 meter. Now he says that you need to find the time. The angle is 14 degree. Time taken to move from S to P. So let's make the data. U is equal to 0. and S is equal to 10 meter. What is the acceleration? 0.13. This is the acceleration. And we need to find the time. Now, can you help me for selecting an equation?
We don't have the final velocity, so we can take S is equal to ut plus half at square.
Right. You need to find T. So remember, for the final step, you have to take a under root also.
I'm getting is at T 12.4 seconds.
20, sorry,
12.4 seconds.
12.4 seconds. That looks fine. This is a very good technique in the paper that some answers look logically right. So this will be helpful because all their answers, they work out with very big practice. The examiners, they always make realistic values. The magnitude of the velocity at t, I think that would be easy now because now we can apply acceleration is 0.13.
It is coming as 1.6.
1.6. The cable breaks when the log reaches the point P. On figure 2.2, sketch the variation with time of the velocity v of the log. The graph should show v from the start at S until the log returns to S. This is a challenging part. This is a challenging part. He says that you have to draw a graph from S to P and then back to S. Let me know one thing, that when the log reaches point P, the cable breaks. Do you think the log will stop immediately at P, or it will first decelerate and goes beyond P and then stops?
It will go a bit beyond P.
Good. And then suppose the log goes up to a new point, let's say X. It will stop there. It will stop there and then come back. When the log is coming back, will it accelerate or decelerate?
It will accelerate.
So we have gathered that picture also. Now we have the graph, and examiner is giving us both positive and negative portion. Why is giving us negative?
For the return journey,
Very good. For the upward journey, velocity would be positive, and for the return journey, velocity would be negative. So this picture is also clear. The acceleration was, what was the velocity when it was moving? The log starts from rest and accelerates at 0.130, which is a low acceleration. So the log starts from rest. So do you think the initial velocity will be zero here?
yes,
And what is the velocity at P?
1.6 meter.
So now help me in drawing the graph. So should I start from zero?
Yes,
Okay, I start from zero. I take a low slope because 0.13 is a small number. What should be the velocity on the point where I have stopped? It should be
1.6.
1.6. Now the objects, what will it do after that? Should I come down or should I go forward with
Go forward.
decreasing velocity?
Yes, with decreasing velocity, it will go forward.
So this is, I have reached point P. After P, the string breaks. So should I take the graph upward or should I take it down now?
After going a bit upwards, it will go down.
I have already reached P. After that, velocity after P, do you think velocity will increase or decrease? The cable has broken.
It will increase.
How? When
Won't
when
start
the
going
when
up.
the string breaks, the object will continue to go upright. But do you think velocity will increase
No,
after?
it will decrease.
Hmm? Hmm.
The velocity will decrease.
Velocity will decrease. So should I take my graph upward? It's a velocity time graph, or should I take it downward?
Downwards.
Very good. I am going to take it downward. Now, the slope is an issue. The object will, I do not know what is the retardation gradient. So I'm taking it down like this. What is the velocity when it touches the x-axis?
0.
Yes, zero. Good. Do you think the object has reached point X?
At 0 velocity, it will reach point X.
Now, what will happen? What will happen after reaching point X? It has a stop there.
It will start moving downwards then.
It will start moving downward. Velocity would be negative.
Yes.
So velocity will be, just a minute. So I have to take it down. So I've taken it down. Should I make it zero again, or if you read the question, or it will not stop at S?
It will go beyond S as well.
Because but he says you have to return to S. So I can stop here because it has reached S again, but it's not, obviously it won't stop at S. It will go beyond S. State Newton's first law.
The object will remain in the state of rest or motion unless a resultant force is applied.
Until an external resultant force acts on it. A log of mass 450 kg is pulled up of a slope by a wire attached to a motor as shown. A very similar question. Achha, it's 2-2 for it. That's a sister part. By a wire attached to a motor as shown. The angle that the slope makes with the horizontal is 12 degrees. The frictional force acting on the log is 650. The log travels with constant velocity. This is a technical concept now. Constant velocity means zero acceleration. Zero acceleration means resultant force is zero. He is asking, is the object in equilibrium?
Yes, the resultant force is zero.
Yes, the answer is yes. He says calculate the tension in the wire.
We'll first label the diagram again like before.
That should be, that you are right, because that is the only way to go forward. I'm resolving it. The object is going upward. If object is going upward with constant velocity, will the value of t will be equal to mg sine theta? I'm asking it because there is another force examiner has mentioned.
The frictional force.
Yes. Where should I show the friction?
Opposite to the tension.
Good. So I have shown friction also. So the equation is there. Mass is 450. Friction is 12. Sorry, friction is 650.
I'm getting 1570.
1570.
Yes, 1567.8. So I rounded it to this.
State and explain whether the gain in the potential energy per unit time of the log is equal to the output power of the motor. Now, this question is not tricky because power of the motor is actually taking it up. There are three possible translations of the power of the motor: kinetic, potential, and work against friction. As speed is constant, so I'm cancelling out this. What are the other jobs left for the power of the motor? Kinetic energy is not increasing because the speed is constant. So the motor is taking it up. when something is going up, it's gaining height. When it is gaining height, potential energy will increase. But do you think some energy of the motor will be dissipated against frictional force?
Yes.
Good. So the answer would be no. Why the answer would be no? Because some of the energy is dissipated to overcome
The frictional force.
frictional force. Very good. So this was a short question, but this is a good conceptual part. So we stop here and we will do it inshallah in our, as mentioned, I'm starting yearly and I will post the timings, or if there is no clash, you can attend those classes, and also you can view the recording always, inshallah. And we are stopping here. Remember to text me the topics or the units which are giving the trouble. Okay. Allah Hafiz.
Allah Hafiz.